better safe than sorry. So if we wanted, for example, hello and welcome to another Retro Crazy. This week we're going to be looking at the Atari 7800. It was released in 1986 for about $80, or if you want to convert it to modern money, $225 today. That's £178, or what's that, 209 euros? The Atari 7800 was designed to more closely emulate the arcade graphics of the era. Strangely, it wasn't designed by Atari, but by GCC, or General Computer Corporation. It used a custom 6502 known as the Sally chip, which was also found in the later 8-bit Ataris, of which I did one recently. And the original 2600 TIA chip, or television adapter chip, was also in for its 2-channel audio in the 7800 mode, or obviously for video and audio, because this was backwardly compatible with the 2600, which the 5200 wasn't. Unbelievably, this was designed in 1983-84, with the initial production run of systems having sat in a warehouse since 1985, and that's all thanks to the Atari sale and subsequent bickering over who should pay GCC for the work on this. By June 1988, about 1 million units were estimated to have been sold, helped by the fact that it truly was backwardly compatible. However, the Achilles heel for the 7800 was the total lack of mainstream games, with only 10 being released in the first 9 months, and overall 57 commercial releases by its demise in 1992. That's about 51 here in Europe. However, having never owned one of these, it is on my list, or was on my list should I say, of systems to grab, including a 5200, which I'll get at some point. I managed to do just that just a few months back, so let's have a look at what's arrived. So I received some standard cartridges: Laser Blast, Dodgem, Adventure and Sequest, the ubiquitous paddles, a pair of Atari controllers, one power supply and one RF cable. It does include the manuals, so that's handy. And in the bottom, the 7800. So the 7800 is not too bad a looking machine. Back to their use of brushed aluminium, I guess, not quite sure. Number of buttons on the front: you've got power, pause, select and reset. On the back we have RF and power in. On the front we have 2 joystick ports and 2 switches which don't seem to be referenced in the manual. They're shown, but they don't actually highlight what they are. I'm going to guess maybe this is difficulty settings like you had on the earlier systems. What I do like, on the underside, these 2 raised sections don't appear to serve any purpose. However, they are underslung, and I wonder if you take your cables and maybe you wrap them around, not just cables lying everywhere. Not sure. Now, one of the things that made this a little bit different was that 6502 Sally chip, that custom, slight modified chip, and the main thing it did was this pause button right at the front. When you press pause, it will actually pause the game, and the 6502 Sally had a single pin way of doing that on the CPU that froze the system in a known state. Normal 6502s, you try that and the system crashes. Okay, we now need to start taking this apart and having a look. So as normal, we're going to start at the beginning with the power brick. Power supplies are dangerous. There are components in these that can hold a charge long after they're unplugged from the mains. So if you're unsure what you're doing, go seek professional advice. So the power supply or power brick for the Atari 7800 is 9 volts DC at 1 amp. It has a very proprietary connector and quite a bit of cable. However, this is what we need to look at. Now, first impressions is this is heavy. I'm hoping it's not potted, I'm hoping it's just a transformer, and there are 2 screws to get in. And there we are, we're in. It's not potted, it's just one chunky transformer. And one cap, anodia. Yeah, do we trust? No, we certainly don't. I can actually see, I don't think the camera will pick that up. That's fractionally bowed. That's no longer flat. Okay, this needs replaced. And there we have it. So, let's plug this in and see what we get out. So with it plugged in, let's find out what happens when switch it on at the wall. No smoke, always happy about that. Let's try and test this without shorting anything. And there we are, I'm making connection now, and about 13.3 volts. Higher than expected, but typical if it's not under load. Right, let's pop this to the side and let's break out the 7800. So with the 7800 back, I think there's about 5 screws. Let's pop this apart. And whilst one side is loose, this side is firmly affixed. There may be a screw hidden inside, but what I can see is a lot of twist points for removing this upper shield. So let's grab a pair of pliers, straighten them, and lift this upper shield off. Okay, I've got the top RF shield off, but I don't see a screw holding this down. Do we have hot glue? Nope. I think we just had a friction fit. Better safe than sorry though. Now the case itself is in lovely condition, it's not really dirty, so for a change I think I'll get away with just the dust. And here we are inside the 7800. Now I can see a whole 1, 2, 3 capacitors to replace, because I just do not like leaving them. And I do have some form of voltage regulator, so I'll pop this off and have a look. Possibly replace that too. What do we reckon? 7805 by that package design? But first let's pop what's left of the shield off. We can see the bottom of the cartridge port. So at this moment all those contacts look fine. There is a way to clean them without having to remove that, so that's fine, we'll do that. But first of all, let's remove and replace these caps and have a look at that voltage regulator. And there we are, that's 3 caps done and a 7805 power regulator. Now I do have to say that the thermal compound they used was pretty dead, so all fresh MX4, and I also have to say the build from the factory is shoddy, so shoddy. We've got resistors, foreshadowing, that are just sitting up right off the board, not even pushed down. These guys here, just so far up off the board. We've got transistors that are buckled with lumps of solder on them. I mean, that one's just been shoved in and bent. It's covered in flux residue all over the place. Underside is just as bad. Look at this. It's just shocking. Factory bodges, and even the solder is looking a bit grey rather than nice shiny. So what I may do is just reflow these pins, because the cartridge port's really important that works. Otherwise, apparently I'm only going to get to play Asteroids potentially. But I mean, look at the lumps of solder from the factory. That's a giant round ball. So with that all done, let's pop some deoxit into the socket, and then we can rebuild. And there we go, all back together, looking nice, hopefully working. Now usually at this point it's time for testing, but we're not finished, are we? That's right, we've got this lot to look at yet. So let's start off with the theoretically easiest thing. We can do these one by one. I'll do one, obviously I'll do the other off camera. So let's see if we can give these an internal spruce up, make sure everything's clean, so they work as they're supposed to. So the first thing I'm doing is getting rid of these elastic bands. I absolutely detest them. When they deteriorate, they just leave residue everywhere. I use, as I've shown a long time ago, I use these. These are Velcro cable ties, and yes, they are genuine Velcro. You just pop them through, and now I can tighten up, and it sticks to itself to keep it neatly out of the way, and that is much nicer than that. So with all this tidied up and out of the way, let's pop this open, and it's 6 Phillips screws. And there we are, down into its component parts. We've got the shell, which, while not being too bad, this is the bit that's held, so I'll probably give this a good clean. You've got your, well, joypad. I think this bit actually is meant to come out, I can't remember. But yeah, that's your joypad, which pushes down on the contacts, which in turn press down on the individual points on the 2 circuit boards, depending on what you're pressing. It's actually not in bad condition. I don't think this has been used much. The pads themselves look excellent. There's no marking on those at all. There's no sign of the shape, which normally happens with things like the Game Boy, being embedded on just from extensive use. That's actually not bad at all. I'm quite surprised. It really does not look like it's had much use. So a small spruce up, and I can pop this back together. So there we are, one controller stripped, cleaned, and back together. I'll do the other one, as I said, off camera, and that one actually does look like it's had more use. The colour is different, it's definitely grubbier, and if I find anything, I will cut back. But at the moment, let's move on and look at the paddles. So last but not least is the paddles. This one definitely looks a little bit grubbier, but that could be anything. Feels nice and smooth. Feels nice and smooth, and to be honest, again, it doesn't look like these have had much use. Okay, let's pop one open and see what's inside. Not a lot as it transpires. It's got an Atari part number. I'm not sure if it was made specially just for this. And this hasn't been used. There's almost no marks on this at all. The previous ones I've seen, they're all scored up the side where the button actually rubs against the casing. And removing the cap, we can show the nut, which should unscrew, allow us to take that off. I'm wondering if I should just pop some deoxit in because of the age. Might be an idea. And then, well, reassemble, because there's not much to these. And that's both paddles done, and I will stick with the fact I don't think these have been used. The second one was cleaner than the first. There's no marks on it at all to show that the buttons have had any wear. Yeah, nice. Well, all the peripherals are now done, and now it's time for testing. So here we are at testing. The moment of truth. Let's get this on. Really could do with it focusing. There we go. So I've got the 7800 all plugged in, RF, which we'll need to tune. I've got the controller, I've got the original titles that came with it, and I've got the one 7800 cartridge I currently own. No idea if it works, because I bought this because it was a good deal, and then I got this. So yeah, now they can go together. First off, let's switch on, go for power. We get green light. Okay, I don't see smoke, that's always good. And now the source followed by tuning. Well, it's trying to output a video signal, but something is a bit wrong. That's a bit annoying. Yep, and how many people are screaming, "You put the system back together, you're going to have to take it apart." Yeah, I know. Back to the drawing board. So we're stripped back down, ready for some hopeful diagnostics. What I've done is I've grabbed the pinouts for some of the core chips, so I can see exactly where the voltages should come in. And next, I'm going to check all the voltages and just make sure we're getting the right voltages out. I believe we are, because this is nice and bright, so let's check and see. So with the basic voltage checks done, power seems to be getting everywhere. For further diagnosis, we are over to the oscilloscope. And now we're on the oscilloscope, sorry for the noise. Let's check that we have a clock on pin 4 of the CPU. And there we are, 1.18 roughly. We should have clock out 1 on pin 3, I think it is. 1.18. And pin 2 should be clock out 2, 1.18. So we've got clock. So next is checking that it comes out of reset. So we're off and straight up to high. So it does look like it's coming out of reset. Okay. So next I'll be checking the address lines just to see that we're running code. So what did the oscilloscope show me? Well, it showed me that the CPU is coming out of reset, that's fine, and certainly there's no activity at all on this LS7432, which feeds U1, which is Maria, which explains why we're getting no video output. I've checked the logic round here and it seems to be okay, it's doing what it's supposed to, and I can see all the clocks on the CPU and on a number of the other chips. However, data lines are dead, there's nothing. Now, halt is sat fixed at about 3.96 volts and it runs through this transistor, and this transistor doesn't look right when I check. I can see the voltage in on the emitter, but the base and collector just don't look right. So I am wondering, is this dead? So I'm going to remove it, and thank you Martin from Techie Kid. I've got some replacement 2N3904s, so I can replace this. So that's next. So let's see what this registers as. Damn, it looks like it registers fine. So I'm not expecting to see any difference if I try powering this on. So I was going to change out the BIOS next, however the replacement EEPROM I got doesn't seem to want to program and fails with an error. I've tried erasing it, it doesn't work. So I can't test this yet, however what I have done is I've received a replacement 6502 SALI, so let's desolder this, drop in a socket and see if that makes any difference. At the same time I'm going to replace the reset button because it doesn't work unless you're pushing down hard on this corner, and I got some replacement buttons just in case. So let's crack on, get this button replaced, get this socketed, and we can test from there. Okay, so we've got a socket in for the 6502. I've replaced the button, so those can go to the side. I've got a replacement SALI, so let's drop this in. Alright, let's plug in and find out what happens. Yes! It was SALI. Holy moly, it was SALI. Okay, right. I think we got a dead chip. Nice big X in the bin. Right. We've got sound. We seem to be going forward constantly. Not sure that's meant to happen. I'm going to guess that there is a trace somewhere that's shorted, which is causing the up button to register as on all the time. So let's have a quick look at the schematics and see if we can work out potentially where this short is. So checking from the top left pin of player 1, which is up, and goes through this resistor to ground, and then should be pin 12 on the riot chip, which it is. Now looking at the other pins, there's nothing else that comes through, but this is one of the resistors that was really high that I didn't like, along with this one when I first opened it, and it's a different resistor to all of the others that are fitted throughout the board. I'm suspecting these resistors, so I'm going to go and check. I should have some replacements. They're both the same value. I'm going to lift this out and check, but I'm suspecting these resistors. So I've got the two resistors out. I actually have one of these capacitors desoldered and just hung loose because I was testing that one just to check. And yes, I was correct. After checking, these are capacitors. These should not be resistors. So whoever has been in this board before has put in resistors trying to do I don't know what. I think they believed they were resistors because the code values when you work them out are the same, and it's totally wrong. Now after checking, these are debounce capacitors. and it just delays the amount of time it takes for the signal to go from high to low or low to high. So the theory is without them it should still work. So there we have asteroids, and now if we start we should not hopefully have the ship jetting constantly. It's not jetting, excellent. Now it should actually still play. Which it does. Yay! Okay, so there's the source. Somebody else has caused the issue by believing that what they were doing was correct. Now I do have the correct, believe it or not, I've managed to track these down. I've got these coming, so I'll be putting this back to absolutely stock, but I'm going to have to wait for that to happen, so by the time you see this next, I'll have it back together. And with everything reassembled, let's find out what happens now. But I've got a good feeling about this. So with the controller in, everything plugged in and ready, let's first of all hopefully play Asteroids. Excellent, let's start. Okay, Asteroids works and I can't play it. Right, what about some of these? So it came with 4 cartridges for the 2600. There we go, it likes Dodge 'em, so we can play Dodge 'em. Sequest, no problem with Sequest. Adventure. Not seeing Adventure. Nope, doesn't like Adventure. So that's one for looking at in another video. And Laser Blast. And Laser Blast works. I have no idea, but yes, it's working. So there we go. We have a fully working 7800. It took me on a little bit of a journey, but hey, that's what happens when you want to repair these things. They can do. So I'd first like to thank a couple of people in this. st-freaks.co.uk. Rupert, you were excellent, thank you, great replacement CPU, but more importantly today I've had a spare delivered from him, which I ordered, so thank you very much. And of course Martin, Techie Kid, your caps are always great, and one of his transistors this time as well. So thank you for watching, please remember to like and subscribe, and I'll hopefully see you in the next Retro Crazy.